Hi, I'm Craig Gibbon.
I'm Brooklyn Vanderwolde.
Hi, I'm Caitlin Hilson.
Our project for this year was to build a more realistic CPR simulator.
So knowing how to perform CPR correctly is very important because incorrectly compressing the heart, either not fast enough or not hard enough, can lead to death or permanent damage to the unconscious person. And people really don't realize how much force is required to compress the heart. Most heart models consist of rigid plastic structures that don't show the underlying physiological processes occurring in the body, they only show what that structure is. Additionally, CPR mannequins used in a classroom tend to be very simple and don't really provide the feedback of whether the user is performing the compressions at an adequate rate or depth.
Our solution to this was to combine the typical CPR training device with the physiological model. This allows students to effectively train for CPR as well as visualize how the blood is flowing through the heart.
So the CPR requirements are the person needs to compress the chest and the rib cage with approximately 100 pounds of force, and they need to compress it 2 to 2.24 inches in depth, and they also need to do this at a rate of 100 compressions per minute.
So for a simulated heart, it consists of 4 transparent valves and 4 chambers, and then you can see the fluid going through the model and you can see how the blood pumps and the one-way valves working. Tank 1 and Tank 2 simulate the heart and the lungs and how that blood flows through the body.
Our heart model contains 2 sets of unidirectional valves just as an actual heart would. The importance of this is it allows students to visualize the valves closing to prevent the backflow of blood throughout the body. You can see an exploded view of one of the valves in the top right-hand corner, as well as an assembled version in the bottom right-hand corner. This video shows a chamber and 2 valves working together. As the chamber is compressed, the inlet valve is sealed shut as to prevent backflow, and the outlet valve opens up to allow the fluid to continue to move forwards. The simulated rib cage is constructed out of a bent sheet of plastic. The purpose of this is to provide the most accurate amount of resistance possible for the user when performing CPR.
So the feedback system is very important because it shows the depth and rate that the person is performing CPR on the mannequin. It shows them the numerical value on the LCD screen, and it also has lights lighting up, green meaning good, red meaning bad, and yellow meaning okay, as they're performing CPR, so they can have a visual light flashing up as they're performing it.
So overall, we developed a CPR simulator that provides realistic force and depth applications with complex feedback. And then the heart model relates the significance of the unidirectional blood flowing through the heart. And this overall assembly consists of a rib cage, 4 chambers, 2 sets of unidirectional valves, and then 2 tanks that represent the lungs and the body.